What is up, everyone? I hope you all are doing well. My name is Ishan, and welcome to the video. In this video, I'll briefly go over the Europa Clipper mission, what it is, but focus more on why Europa is such an interesting place in our solar system that we want to send a space exploration mission out there to study its environment. This is going to end up being part of a series of videos since there's a lot of information to cover and unpack, so be sure to hit that subscribe button so you don't miss out on any of the future videos. Welcome to part 1, and let's dive right into it. NASA's Europa Clipper mission is one of the first space exploration missions that is going to perform a detailed analysis of an ocean world in our solar system. It is set to launch next year in October of 2024, and it's gonna insert itself into Jupiter's orbit around April 2030. It's an orbiter mission, meaning it will perform flybys, but nothing is actually going to land on the moon. Europa Clipper's main science goal is to determine whether Jupiter's icy moon Europa has conditions under its surface that could support life. So it's not necessarily looking for life itself on Europa, but rather confirming if there are habitable conditions where life could emerge. And I hope by now that you're probably wondering, why Europa? In the search for life outside of Earth, we try to seek life as we know it here on Earth, but there can also be life as we don't know it that has completely different biochemistry. Currently, we focus on seeking life outside of Earth by trying to find the conditions that are present on the Earth now or were once present on the early Earth. Life as we know it needs 3 key ingredients, which are liquid water, a chemical inventory of certain compounds, and a consistent source of energy. Jupiter's icy moon Europa is one of the places in our solar system that meets all these 3 key requirements. So let's talk a little bit more about what Europa actually is like and what we know about it so far. Talking about Europa's magnetosphere. The magnetosphere is a region of space surrounding a body in which charged particles are affected by the body's magnetic field. It is created by a celestial body that has an active interior. So for example, the Earth has its own magnetic field because it is geologically active. The Galileo mission showed us how Jupiter's magnetic field was being disrupted around Europa, implying that Europa had its own magnetic field that it was creating, and it was likely that it was being induced within the interior by a deep layer of an electrically conductive fluid. This is one of the key pieces of evidence that leads us to believe that there's a salty liquid underneath its icy shell. The Europa Clipper mission has instruments on board to study this induced magnetic field that Europa has. Talking a bit more about Europa's atmosphere, it has an extremely thin oxygen atmosphere, but we have noticed some activity in it. NASA's Hubble Space Telescope found evidence that Europa might be actively venting water into space, which is another reason to believe that the moon is geologically active currently. Other gases might also be leaking out, and dust particles are blasted off of Europa's surface by micrometeorites. The Europa Clipper spacecraft will search for any water plumes and study other properties of its atmosphere. Heading down to Europa's surface, it has a water ice surface that has a small number of craters. As Europa orbits around Jupiter, it's in an eccentric orbit and it experiences strong tidal forces, somewhat similar to what we see here on Earth, where the tides are caused by the moon. And these forces cause Europa's icy outer shell to flex, and that repeated flexing leads to cracks, ridges, bands, pits, and domes that cover much of its surface. The mission will give us better resolution images than ever before to map out the surface, along with its composition, temperature, and roughness. The ice shell is estimated to be about 15 to 25 kilometers thick, but we don't really know that for sure, and the mission will help us confirm the thickness of the ice shell. As we head down underneath its surface, there are different pieces of evidence that lead us to believe that there is an ocean underneath its icy shell. Number 1, there are patterns of linear features that don't fit the predicted patterns of fractures. In simple terms, this just means that the surface is moving, or at least that's what the surface features suggest. This wouldn't be possible without a liquid layer underneath its surface, or at least slightly warmer ice between the crust and the deep interior. Tidal heating is another reason we believe that Europa's interior is warm, and if it is, that water ice that exists underneath its surface would certainly melt, creating liquid water. And like I mentioned earlier, Europa has its own induced magnetic field, indicative of an electrically conductive fluid beneath the surface, and given its icy composition, it is likely that it is salty liquid water. As we keep going further down into Europa's interior, it has a rocky interior between the expected subsurface ocean and its core, and the main reason this is important is because we might see water-rock interaction in its seabed, similar to what we see on the deep sea beds here on Earth, where there's an inventory of mineral and organic compounds in hydrothermal vent systems. In these vicinities, the building blocks of life can emerge, giving rise to simple microorganisms. That wraps up a quick overview of Europa's atmosphere, surface features, what's underneath the surface, and the key pieces we have that lead us to believe that it hosts a salty, liquid, subsurface ocean. And I hope it's more clear as to why it's such an interesting place and why we want to send a spacecraft and a space mission that's dedicated to studying this place more. But now that we have this background, in the next video, I want to go deeper into the science objectives of the Europa Clipper mission and the instruments on board that is going to help us address the scientific goals. If you made it this far into the video, I really appreciate you tuning in, and I hope you learned something new. If you did, be sure to hit that thumbs up button, comment down any questions that you have, and don't forget to subscribe so you don't miss out on any future videos. I'm going to see you all in the next one.